But then who does estimation in the context of Agile? So for example, if you want to paint a house, as we discussed before, if you want to paint your house, who is the best person to give an estimate? Is it the boss of that particular company who doesn't have anything to do with painting, or is it the accountant, or is it you? None of us. None of these people are best placed. Who is the best person? The person who is actually doing the work, the painter, is the best person to actually give you an estimate which is closer to the reality. What you have got an estimate, the idea is perhaps it's good to have an estimate, but then your estimate might be way off tangentially in terms of the reality or the actual that is being done on ground. So in the same context, with the IT, the development team should estimate. There's actually a saying that I keep repeating every time within the Agile context. Even on Thursday, I'm going to repeat the same. Development team should estimate, they should commit, and they should deliver. That's the whole mantra of Agile. The reason why Agile development has been successful is because the team estimates, the team commits, and the team delivers. Nobody else. It's not your boss, it's not the client, it's not somebody else, it's not the subject matter expert. Everything is actually being done and being owned and delivered by the team. The team owns it, and that's why Agile is successful, period. It's not successful because they're delivering something quick or anything. It's because when you have got the sense of ownership in terms of what you're doing, you take more and more responsibility, and you actually feel that freedom. You've got that responsibility on your shoulders, so you feel more committed and more and sincere towards your work. That's the whole objective of Agile. It's about team empowerment. So in the context of Agile, it's the development team that does the estimate. So I'm not talking only developers. I'm talking about, for example, as a team, the analysts, developers, designers, architects, all of them obviously would be involved in the estimation exercise. But then when it really comes to this, it's not being dictated by the project manager, by the scrum master. It's not being told by the customer. The customer might give a rough timeline saying that I want this feature, the e-commerce or the shopping cart feature by, let's say, September 2021. Or they say, I want to go to the market by April 2021. So they give a rough timeline, but they cannot dictate in terms of the how much time or what is the size of this particular piece of work. So it's the development team, it's us who should do that. So user stories in the sprint backlog need to be estimated. We've had a look at it already. The tasks, the requirement changes, the change requests, the defects, all of them, everything need to be kind of estimated. It cannot be left for choice. When we talk about user story points, it's not just the user stories that get the points and the estimates. You leave out the rest. No, it doesn't mean that. It means that you need to estimate every single item in the backlog that needs to be. For example, in your sprint backlog of about 10 items, that's why we call it as items and not stories. Backlog is not all about stories. This is another important thing. We'll talk about each of these in the Agile course in detail. A backlog consists of, let's say, 10 items. We call it as items. Each item could be a story. It could be a change request from the previous story. It could be a defect that is logged by the customer or by the testing team. Or it could be a new requirement, for example. All of these, it could be a task as well. It could be a task to create a table in a database. It could be a task to fix a piece of code. It could be a task to add a user. All of these could be the tasks. So when we talk about 10 items in the backlog, you need to estimate all of the items, how much effort it would take to complete those 10 items. And that's why we call them as sizing. That's important. You're not talking about the days. You're not talking about one person might be taking 10 days to complete it, whereas the other person might take 1 day, depending on the experience. That's why what we do is we do the sizing. It doesn't matter. So again, going back to the example of the painting the house, you don't ask like, how much time do you have? Do you want me to finish off in 2 days? No. The first and foremost thing that the painter would ask is the size of the house and what does it take? Similarly, the first thing that you would like to ask in terms of building an e-commerce website is the number of pages. What is the functionality you would need? The number of pages, the kind of functionality you would need, for example, could be building a shopping cart, building a catalog, how many products do you have? And then the payment processing, who does that? Is it your responsibility or somebody else? Yeah. And then how do you actually kind of accommodate all of these in the context of the mobile application? So mobile application, or is it only website? Does it have to be a responsive website as well? So all these things, which kind of operating system should it be used? Is it for iOS or is it for Android if it's a mobile application? If it's a web application, should it be hosted on a Linux environment or should it be? So all these questions would actually give you a fair idea in terms of how you would like to approach, where you would like to host this. So similar to the point about the painting the house, the fundamental aspect is the size of the piece of work. It's not the effort, it's not the cost, nothing else. All of those would follow from the size. So if you ask me, the way I would approach anything in this in estimation is, first thing, estimate the size. Next, estimate the effort that is involved in carrying out given the size. So size is the fundamental. After size and effort, you look at the number of resources that you have. It could be the number of people, number of tools, applications. For example, is it only hosted on the Linux environment? Don't bother about mobile application. That's fine. Need not be responsive. Or if they say, I won't have this. So that's also resources. Should it be scalable to 5 servers? Should be network balanced? Should be load balanced in terms of the network? So all these things need to be factored in. These are the resources. There's the soft and the hard resources. And then once you have the size, the effort, and the number of resources, you would then be able to come up with a schedule, whatever you call it as, the duration, the number of days, the number of months, the number of years, number of hours it would take to carry out the task. And then finally, given these 4, the size, the effort, the number of resources, and the schedule, you'll be able to arrive at the cost. Because you've got an idea now with the resources, it could be a simple case of number of resources times multiplied by the resources, for example, by each rate of the resource. And then you would arrive at the particular cost of the resource, add to the cost of, for example, variable costs and the fixed costs, for example, the hosting, for example, Google Cloud or Amazon AWS or whatever, they have a fixed cost. It doesn't matter in terms of how you would like to host. There's a fixed component and then there is a variable component. So you actually add all of these components and finally arrive at the resource cost. And that's the total cost of development or total cost of ownership. So I would still reiterate, whatever you're estimating this whole world, whether it is IT or non-IT, start with the size as the fundamental measure. Size up. Look at what is the quantum of work involved in the first place, then the effort, then the resources, then schedule, then finally the cost. So that's how it would really work. It's not the other way around. And estimation is best performed as a group. Because sometimes subjectivity kicks in and the experience of the person, their awareness of their own technologies and the tools, and their understanding of the system, the requirements, everything that would kick in. So to kind of have a broad base across different people with different backgrounds, different experiences, different technologies and different exposures, what we can do is to actually kind of have a group dynamic come in, so we can have this average context. So you don't really kind of, law of averages would kick in there. And then we can have that's why they say, give me 3 estimates, the worst case estimate, the normal case estimate, and the best case estimate, right? So it's what is the best one, what's the best scenario, what's the worst scenario, and what's the average scenario. And then you can actually have a weighted average in terms of these, and again, come up with the base level. So it really depends on that. And then in the context of Agile, for example, again, going back to this painting the house, somebody who's really experienced could actually say that, oh yeah, it would take about roughly 10K pounds to finish this. But whereas somebody else might actually say it would cost about 4K. On what basis are they saying? They're based on the relative estimation. They're not absolute. It's not absolutely, they're not looking at each of the rooms in the house. They're not taking a tape at that point of time. Obviously they would do it later, but at that point of time, initial quote, they won't really have the detailing, the measures and everything else. So they're really trying to compare it with something in their mind, in their brain. They're going to benchmark this house with something else they did before. So it's basically relative estimation. In the context of the IT, the agile estimation, the user story points as well, we use relative estimation. It's not absolute measure. Nobody can actually see a particular screen and say, okay, this is the exact thing, because they have not even seen the screen. The wireframe is not even ready at that point. So what are you basing your estimates on? You're actually basing it on something else, which is similar in size, in shape, in complexity, in the completion of the work itself. So based on all these factors, you would then be able to actually say, well, because of the fact that that is similar to this, it may not be identical, it is similar. So I presume it would take roughly, it is of similar size, so it would take so much of effort or so much of duration to finish this, and so it would cost so much. So that's the relative estimation concept, very important. That's why we actually use the t-shirt sizing. So it's a large for you in your organization might actually mean a medium for me. A 13 could be a large for some of the teams in terms of the kind of work that they do. Whereas if you compare another team which is sitting next to them in the same company with the same office premises, the next development team, for them, a 13 could be a small size, because the complexity of their piece of work is different. The kind of project that they're working could be different. It could be a development enterprise application compared to this team, which is actually trying to develop, let's say, a run-of-the-mill website, e-commerce website. So we have a better idea in terms of how the better handle, better appreciation in terms of what the functionality of the e-commerce website is compared to something else, which is fairly complicated, right? So all of that would kick in. So we'll have a look at some of the factors in the next few slides that would play in. So the first things first, as we discuss, some of the questions that you need to answer is, how much effort is required to complete an activity? Yeah. How many calendar days are required to complete a task? So that's the time of the duration. What's the cost of an activity, one activity or a task? And what is the total cost involved in a program, project, whatever? So you're really talking about this in the context of, as we discussed, effort, duration or schedule, the cost. But the most fundamental aspect of all of this is that we are missing is the sizing. What is the size of the work? If you know the size, you can get to know the effort. If you know the size and the effort, and perhaps how many people you have, the resources, you can come up with a schedule. And if you know the schedule and the number of resources, obviously you'll have the cost. So I think that's the most logical way of approaching things. Need not be the same every time, but I would say sizing is very, very important. So how do you estimate? You start with the size estimation. So that's important. You need to understand the size of something. Is it big? Is it small? Is it medium? So it really depends on how you would actually get to that. Now, what you define as big vis-a-vis what I think is big. So you need to have some kind of benchmark for that. And that's why, we use t-shirt sizing, because the t-shirt sizing don't really vastly differ so much in terms, at least one geography or region. So that's why we've got Europe or UK sizing is slightly, which is all consistent, fairly consistent in terms of, for example, if you compare that to the US, they've got a completely different way of sizing. But still there is a standard, right? So there is a US standard sizing of t-shirts, which is one standard which is compatible with all the people in the US, whereas it could be different from those in the US, from the Asia and from Europe. So you need to have that kind of a rough idea. We're talking really rough idea. Nobody's really interested in the specifics and give me the exact number. So if that is the case, there's no point of estimation in the first place. So the input for this kind of size estimation is the requirements. Unless you know what you want to develop, what is the vision for this? You need to know the vision, the requirements, the stories, the functionality, the house. Unless you have these, how can you really kind of estimate? So that's where you need either the images of the house, or the dimensions of each room in the house, or you need to have a blueprint of the house architecture, or at least some idea, just some numbers. Give me the number of rooms at least, right, in the house, so that I can come up with the quote for the painting. How much paint do you need? How much of wallpaper do you need? How many walls do you have to have the wallpaper in? How many coats do you need to have? Do you have single coat or double coat of the paint, right? All of these will kick in. Do you want different paints for each room or the same? So all of these are required for you to be able to actually arrive at the size of the house, first thing, right? So that those are all called what we call as requirements. The ability to add the items to the catalog, that's a requirement. And then the processing of the functionality to remove the item or to actually change the number of the quantity of the items, again, that's a functionality. So when you give these things, then you know, oh, these are the areas that the user would actually kind of interact with the system, with this website, e-commerce website. And then accordingly, you can actually have you can apply the productivity. So once you have the size, then you actually kind of look at the productivity. We were talking about velocity, right? So velocity in the context of Agile is roughly equivalent to productivity in the normal term. So productivity is, for example, if a painter is able to paint one wall in, let's say, 1 hour. I'm just giving an example. So that's the productivity of this painter. You know what? It's not the same for every painter. One painter who's experienced, who's got the roller, for example, he's using roller. He's using a roller painting to use this, paint for this house. He can do that in, for example, 1 hour for one wall, right? And the same wall, same size, yeah, same size of the wall, the same paint, for example, similar paint. Let's not change those variables. Then somebody else who's using a brush he's not using a roller. He's actually using a brush. That person might actually take 2 hours for doing the same wall. So what you're trying to compare is the same set of variables. That's something which you need to consider. And so you need to have a clear picture about the methodology. What's the kind of methodology they're using, the tool they're using? Is it the brush or the roller? Are they using Visual Studio.NET or are they using Java? If they're using Java, there's completely different. If it's C# coding, they're using Visual Studio.NET, then potentially two developers could potentially have the same set of level of productivity. But you know what? There are other factors. The person might be junior. They may not have enough experience of working with Visual Studio.NET. In that case, again, the productivity might be lower than the person with 5 years of experience with more exposure to using .NET, the Visual Studio.NET tool. So you need to understand also the phase in which you're working on. So if you finished one code and you're just giving a rough code the second time around, then it doesn't take 1 hour, right? So you're talking about some of the variables, dependencies in that context. Similarly, if you already have a database and you have some table already there, the data is already in there. You don't need to even migrate that data into the new database. Given that, then the effort and the productivity to actually code something is far, far simpler than, for example, in a case where you need to completely rebuild the database. You need to have a database. You have to design a database schema. You need to come up with a model for the database. You need to actually start, putting the tables into the database, into a SQL database, for example, create an SQL database, add the tables, add rows and columns to each of the table, define the table, and then, import the data into this table. Or if you don't have that migration tool, you have to actually manually do the migration into the porting of the data into this table. So there, the productivity would take a different meaning there. So you need to really consider each of these, and then convert the size into standard effort. So that's where we were using simple tools before, simple kind of formulae before, and that is effort is equal to size divided by productivity, something like that. So it's easy for us to actually kind of come up with this kind of thing. So you can clearly say that, for example, if some painter takes 1 hour for painting one wall, it's easy for you to know that if one room has got obviously 4 walls and, for example, a similar sized ceiling or roof, you would have, let's say, 4 times that. You've got 4 of them plus 1, 5. So 5 hours per room is rough estimate, right, for one coat. So you actually have, like, say, you've got 2 bedrooms, 2 times 5, 10, and then you've got, let's say, a hall slightly bigger. Let's take some of the other things into consideration, slightly bigger. So add another 2-3 hours there. So you've got 10 plus 17 for the including hall, and then a kitchen, yeah, rough estimate again. So another 5. So 22 is roughly for a small house with 2 bedrooms, 1 hall and a kitchen. But is that as simple as that for a website? Could be. Why not? It could be just I've got a home page. I need 2 inner pages, and I have got 1 registration form to fill, and then maybe 1 login form, for example. If this is the kind of thing that you're talking about, then you have a rough measure there already, right? So you've got a home page. So we talk about in the context of a house, we're talking about a bedroom, kitchen, and a hall. In the context of a website, it could be a home page. It could be what we call as a list view. So you actually have some of the list grid view or a list view where you actually kind of show the information in records. And then you can have a form view where you actually enter the details, input, user input, UI. So that's a form where something like a registration form or something like a login where you actually input something, enter something, the user. So that's a form view. So if you say roughly a website having 1 home page, 3 form views, and 4 list views, and perhaps 2 or 3 detail pages where you show the detailing in the form of the data is shown in the detail, where you can't enter anything, but you just have the details, all of the 2, 3 images here and there, some text, and maybe some other video or something like that. So that's roughly, you've got an idea that it has got 10 pages. Each page has got different complexity. So you can multiply that, and then you can come up with a rough estimate again. So you're actually trying to convert that into the size. From the size, you actually can convert that into an effort using the productivity. You can then say a developer could actually kind of churn out, let's say, 3 pages per day of average size. So you can actually have that as a productivity figure, and then you actually have the effort coming in from there. And then adjust efforts for schedule constraints. So once you have got the effort, then you actually have the schedule. So sometimes you have no idea. It might be taking 6 months, 9 months. So that's where you need to take a break to actually kind of understand what is the timeline imposed by the client. So sometimes it could be like, in the next 3 months, I would like to have this feature. Don't worry about everything else about the website, but you know what? I need to have by April 2021, I want to have at least a catalog, and I should have at least functionality to do the shopping cart, so that you can add the items into this. Just focus on this. If you can do this, that's fair enough, is what the client would say. So the business, that's the business timeline. There's a business imposed restriction. So you come back and you work backwards. So given those 2 functionality epics, how can you kind of get into details of those, and then you create the overall plan for that, the stories, and from there on, story points, estimates, the tasks, the database requirement, the user interface requirement. If it's a registration, login page should be there, registration page should be there. There should be a page where it shows the number of items, and you should be able to change it. So that's the input, that's a form view. So you should have a shopping cart as a form view. So you can have a rough idea in terms of how we're going to proceed with that. So again, very important for you to understand that sizing is the most important, and then comes the productivity, effort, from there, the number of resources, schedule, and finally the cost, right? So that's the most important thing that you should remember. And in terms of the approaches to estimation, we talked about different ones. So for example, we mentioned top-down estimation, bottom-up estimation. Top-down is where you actually have a rough idea in terms of comparing that to something else. And that's why you actually have the initial one I was talking about, the painting of the house. The first house on the left was a simpler one. You have a rough idea in terms of the size of that. So you say, oh yeah, roughly it would take 10,000 pounds for, I'm just giving an example, for 2 coats of paints with this, blah, blah, blah. Whereas on the house on the right that you had seen is very complex. So I'm just going to go back to that, sorry. So it's fairly complicated, right? So you don't have an idea. You need to actually get down to that. You need to actually take measurements, the dimensions, how many rooms are there? What are the dimensions of each room, right? And then for that, we should actually kind of look at, does one wall have a wallpaper, or is it 4 walls of the house the same paint? So all of these detailing would come in. They'll take the measure up stuff, everything, and then they'll be able to come up with a proper estimate. Again, that's an estimate, but then that's actually working to, in terms of bottom up, going to each and everything. So in a sprint, in an agile estimation, that's actually bottom up. The developers would take each task and then understand what is involved, and then come up with the story points. So this is a bottom up estimation, whereas In the previous days of functional decomposition, we used to do the top-down estimate. And then absolute estimate is for that house, the house on the right. That's the estimate that you come up with based on all the measures, the dimensions, looking at each and every room and getting a feel of it, noting down the dimensions, and then coming up with the number of coats required, the amount of paint required, and then perhaps the number of brushes or the rollers required, the number of painters required, the skill sets, all of these. Actually, you're talking about that particular house. It's an absolute estimation. You're not talking about something else. Whereas the relative estimation is the one on the left, you're using just some rough guesstimate as what we call. Say that, okay, I've done a similar one in the house about 2 years ago in a different place, but it's a similar one. So I'm just thinking, roughly comparing the size. Yeah, it's a tad bit smaller, but I think I'll just go with a slightly higher figure just to be on the safe side, is what some of the professionals would think, right? So they'll give, anyway, I'll go with, it should actually roughly cost not more than 7,000 pounds. But he'll say, you know what, just keep 10K, just so that you're covered on all bases, and applying inflation and all those other things into the whole thing. So relative estimation is what we actually tend to do. The t-shirt estimation, planning poker, this is all relative.